in biophysics at the University of Split in Croatia. He is a researcher and a member or a leader of different national and international bodies in Croatia. And today he will be speaking on enhancing student engagement in high school by designing research in higher energy physics. And again, I'll give you the cards on the screen. So thank you very much and welcome.
Thank you, and good afternoon and good morning, it seems, to everybody. Well, as already presented, I'm professor of physics at the University of Split, and now, briefly, within 15 minutes, I hope, I'm going to present you one very relevant research activities with the team of high school students. It means between 16 and 19 years of age, and also their mentor, and also how in the future we could use similar opportunities in order to enhance student engagement here for us in physics. Just a minute. So creating a culture of excellence and working with talented students is or should be an important role of teaching in all high schools, but also universities, of course, especially when we are talking in natural sciences, STEM, and such as physics. By involvement of real scientific research activities in all areas of physics, talented students, of course, can achieve various knowledge and also skills and competencies, especially when we are really in physics talking on high energy physics. There we have opportunities to discuss about complex laboratories, theories, etc. And of course, this is very dependent, such activities are very dependent to collaboration between high schools, universities, researchers, and also even researchers at excellent technology attractive laboratories, such as, for example, here, in this case, CERN in Geneva or DESY in Hamburg. In fact, really a new dimension of research activities of talented and motivated students can be achieved by really well-organized collaboration between researchers, teachers, and high schools. Okay. Sorry. We took one opportunity that was, in fact, already existing 7 years, Beamline for schools. This is the international competition. And so in working with talented students, so we decided this time to use this opportunity and to create a team and to go through a real design of research activities. For example, within, at least in Croatia, within usual high school curricula, regular, topics on modern physics, are mostly at the level of facts, not more than that, or let's say implementation of very basic concepts and principles to even unrealistic systems, so imaginary. So, as I said, we decided to use this opportunity and to create a team of motivated, talented students and to go to the international competition. In order to be able to compete, so it was necessary to design real research project according to laboratory that was presented by CERN and DESY institutes. So many challenges then appeared within those preparation. Here on this slide, you can see how it was how the competition is attractive last 7 years. I don't know whether you are able to read, but more than 11,000 students already were on last year, so where they are on the competition. And this year, in addition, there were 289 teams of students from 52 countries only this year. And after the results and the real review by researchers, only 26 of teams were shortlisted. And last week we got a message that even our team was shortlisted, so the team of students were very happy. So, the main idea was to design real research project according to set of instruments we were able to, in the future, were able to use. So the various actions then we set by students, within students, even while asking, trying to find the motivation, trying to find the objectives of the research, what our research should be focused on. And of course, the very simple, let's say, element to set the hypothesis and elaborating a theoretical base. So many questions were set down, and some of them you can see on the screen. So what topic, in fact, could be researched and why? So, and who are the main users of the results? What are the potential benefits of the results that we are going to achieve by the research? What is the hypothesis? What is already known in relation to the hypothesis? Literature, about literature, what is the theoretical base? So all of those elements, because here we are talking about real research in high energy physics, was quite unknown to students. So let's go on. So for the so it was really challenging for the students even to set the hypothesis. So how to help them? So we decided to use tools that usually we can find at the level of researchers in high energy physics. One simulation package, GBOO, it is theoretical simulation package that could help if used properly to understand some basic reaction system of subatomic systems. Well, of course, hypothesis should be attractive, should be feasible for students, understandable for students, but also at the same time accepted by the researchers as a real experiment, to be used for the experiment. So the students analyzed the different properties such as cross-sections as a function of beam energies, because beam energies was already set by the organizers. So of electrons to nuclei. So, and also they discussed about the particles they would like to analyze, and they decided to use, for example, pions. And they needed to analyze different literature. For example, here some of them are very, research-based, very scientific. And also the package they used for the simulation in order to understand the systems they would like to research was quite complex. They needed to download the software package to prepare and to install to the Linux system. Before that, even to understand Linux system, because it's quite different comparing to Microsoft. And to run, to analyze data, etc., that was quite challenging. And that was prepared in a way that only we, as the researchers, help them, just guiding them, not helping in a real steps they needed to do. So here, after a series of discussions, lectures, simulation, etc., students agreed and suggested this hypothesis that they would like to use pions, and the ratio of number of well, this is for, of course, for physicists, of positive and negative pions formed in the reactions of electrons to nuclei in targets, as they suggested, should depend on the quark structure, and this should be reflected to the cross sections. So that was really interesting for them to decide about this hypothesis. So, well, because here we are talking about activities with students, so a very important step is also to assess achievement of learning outcomes, even to set which set of learning outcomes we expect they should achieve. And some of them you can see here. Well, of course, we are talking about basic learning outcomes. Thank you. Learning outcomes in high energy physics, well, to describe, for example, basic characteristics of elementary particles, to apply concept of special theory of relativity, to explain trajectories of charged particles in magnet field, etc., up to cross-sectoral competencies, for example, responsibility, collaboration and communication between team, but also communication with well-established researchers in CERN and DESY institutes. So different set of specific learning outcomes, but also cross-sectoral. And I'm going to do. And so the science project activities as presented in this paper and here briefly were very motivating for our students, this team of students. They were 6 of them. So enabling process also for both for students, but also for teachers at high schools, but even for us at universities and research institutes. So there are even additional opportunities for the future, as we discussed, to make, for example, contacts to students from other schools, I mean, with that were also on this competition, and countries, in order to, for example, create a joint team, as well as to contact talented students, for example, not only for physics, but also from different fields, in order to make interdisciplinary activities. And well, for the conclusions, here you see, I mean, some of the pictures. So even we created, or students in fact created a short video that was also obligatory, and they were very satisfied with the approach, very motivated. That was activity within 3-4 months during the school period. And also teachers, the mentors, the school, very, very motivating, and they would like to continue. And that was very interesting for them. Last week we got a message that they were shortlisted, you see, 26 among 289, which was, I mean, and in addition they will get a kit to build a do-it-yourself particle detector, which will bring additional activities to the schools. So thank you all, and if you have any questions, thank you.
Thank you very much. It was really interesting. Other questions? Well, people might be typing them in. One of the things that impressed me was that the students came up with a hypothesis. So it's student-driven rather than having somebody else tell them, you know, what they need to do the project. Do you want to talk about that for a minute?
Yeah, yes, sure. Well, all activities, in fact, were done by students, but we, researchers, teachers, mentors, we were support, asking questions, answering, guiding if there were some, I mean, mistakes, or really putting them to even to create a hypothesis. All steps, all steps.
That's
and
great.
that was, I mean, very interesting for them. You know, they were happy that they feel that they are talking about real research activities at a very advanced laboratory at CERN and DESY. Wow. They are two most famous laboratories in the world.
And how old are these students?
They are 2 and 3rd grade, so it means 16, 17, and 18 year old.
Good.
Not last year in the high school, because in Croatia they are quite stressed with the state matura. So it was not easy to work with the last year in high school with the talented student. They are, stressed by usual activities, but 2nd and 3rd grade students are very motivated to continue.
Good. Are there other questions? Okay, I have one more.
It was a question about physics graduates invited. Yes, also our students from the University of Split, also we asked them to, and some of them were also part of that. But not as a team, as a support.
So do you have a follow-up study where you longitudinally track where these students end up in their careers or further studies?
Yes, well, 3 years ago, also we did similar activities. So we were part also within the same international competition, but without the success as now. We were not shortlisted, and a team of that time of those students, they are very good. Continuing with at the university with a great success. And now this team, I'm sure they will succeed. Maybe not all of them will choose physics as a major study, but it's not important. It's not the idea to have them, only at physics study, but still, for example, this year we have a few additional number of students submitting to be a part of our university. So it seems that such activities with high school students also could help to our university to bring newcomers.
Great. Wonderful start for the students. Anyone else? Many people are saying thank you. Okay, I think we will move on to Elena, I think is our next presenter. Elena Boldareva is a PhD student in curriculum and teaching. You want to make your video, Elena?
Yes. I hope it works. Yeah. Hi.
A PhD student in the curriculum teaching and learning department at the University of Toronto, Ontario Institute for Studies. And today she will be sharing with us how a learning community model can improve student collaboration and understanding of